Hello everybody. So according to my recent poll on our YouTube channel, so my topic for the video is inverse of a matrix. I will try my best to cover this huge topic, but how much I will cover, it will help you a lot. You want to do better, you have to practice more with all these things, but most of the part is going to be covered in today's video. And let's start. Inverse of matrix is denoted by A inverse, and that's another matrix. When multiplied with the matrix A, the resultant is going to be the identity matrix, or sometimes we are saying unit matrix I. Mathematically we can say A inverse, A into A inverse, or A inverse into A, that's equal to I. So that's a unit matrix. How it look like, you can see here an example of identity matrix of order 3 is going to be the diagonal 1 1 1, and all other entries are 0 0 0. So important note, so there is something we need to consider before to go for inverse of the matrix. So number one is, not all the matrices have inverses. If the order is not 3 by 3, 4 by 4, 5 by 5, or in other words you can say if it is not a square matrix, then you can't find inverse. To find inverse we need a square matrix. So order, number of columns, number of rows need to be exact same. So a matrix must be square matrix. So then the next important thing is, you must have non-singular matrix. What do you mean by non-singular matrix? Because we are going to find the determinant value of the matrix, that should not be equal to 0. If it is 0, then it's a non-singular matrix. Example, so your answer is going to be 0. One row or column need to be 0 for to be a singular matrix. So if that is not in the case, so then we can find the inverse. Otherwise inverse is not possible. There are some useful terms. So minor. So what do you mean by minor now? So the minor of an element in a matrix is the determinant of the matrix formed by removing the row and column. So if we will remove for that specific entry the row and column, and the remaining part as determinant value is known as minor. For element ij, so remove the ith row and the jth column, so from the new matrix, so then find its a determinant value, that would be the minor. So next term which we will use in the inverse is cofactor. But cofactor means cofactor of aij, so ith row jth column is negative 1 power I plus j, so that will give the sign to that whatever the entry we are going to use for the minor of a of ij. Determinant, what determinant means, to find the determinant value, go by a row or a column. You can go by column too, but usually we are going by rows. So sum up the product of each of the element and its cofactor. So we have to find it out. So when we will go in there, so you will see what I'm trying to say in detail. Then we have adjoint. What adjoint is, adjoint of a matrix is a transpose of it's a cofactor matrix. What do you mean by cofactor matrix? We already discussed. Transpose means if let's say first row, that will become the first column of the matrix, and second row will become the second column in that matrix, and so on. If it is 3 by 3 matrix, so all 3 rows are going to be converted into 3 columns. So that's also known as transpose of the matrix. So these terms we are going to use again and again, so those are important. So I'm just trying to show you this. So how the inverse of matrix we will find? There are two methods to find the inverse of a matrix. So number one is determinant method, and number two is elementary transformation method. So first we will discuss the determinant method. So determinant method is, if you will see, inverse of a matrix is A inverse is equal to 1 over determinant value of A into adjoint matrix A. So you have to divide adjoint matrix A by determinant value of A. This is simple solution of any ABCD is also given, but that would not give you full exposure of this topic. To go in detail, so let's do this example so you will understand better so what it means. Find the inverse of the matrix A by using formula. So which formula? The formula which we recently set the determinant formula. So let's use the determinant to find the matrix inverse of this matrix. So we have the matrix A, and that's equal to, it's a 4 3 8 and 6 2 5 and 1 5 and 9, and we are trying to find the determinant value first of all. So determinant sign, as you know, it's A determinant is equal to, so I have to go by row. So row number 1 is right here, so I'm going to go according to row number 1. So first of all, negative 1 power, so first value is element is 4, so first row first column, so 1 plus 1 into 4. And now we have to go with the determinant value, that's going to be 9. 2 times 9 is 18, and minus 5 times 5 is 25, and plus negative 1. So second entry in the first row is 3, so that's the first row second column, 1 plus 2 into 3, and now I have to leave these two. So what I'm trying to do, so I'm trying to go by this way. So if let's say this and this, these two you have to leave. I'm just giving you this example in between so you will understand, so from where these numbers are coming. So 6 times 9 is 54 minus 5, 54 minus 5, and plus the last entry in the first row is 8, so that's a negative 1 power, first row third column 3, 8 into, so now because we have to leave the first row third column, it's a 30 minus 2, 30 minus 2, that's 6 times so 6 times 5 is 30 minus 2, so this is equal to 4 into negative 7. If you will simplify, and this is going to be minus, now it's not plus, so minus 3 into 49, 8 into 28. If you will simplify all this together, so you will get 49. So therefore my determinant A value is equal to 49. So let's keep it and move forward for the next step. For a joint matrix, first of all I have to find the cofactors of matrix A. So how we will find the cofactor? Method is exact same, but we are not writing the entries. Instead of entries, we are going to write the determinant values. Example, so I will write cofactors of matrix A is equal to, I'll write a little bigger because we need all these things. For the first entry 4, so it's a negative 1 power 1 plus 1. Into, you have to write the same determinant value, that's going to be 18 minus 25. If you want to write, I can write for 18 minus 25. Second entry is 3, so 3 is not going to come in, so it's again negative 1 power 1 plus 2 into, so this is going to be 54, 54 minus 5. Last one is negative 1 power 1 plus 3, and we have this 30 minus 2. Similarly, the second row, it's a 6 is the entry, so that's the second row, so negative 1 power second row first column, and we have this 27, so 27 minus 40, minus 40, and next entry is negative 1 power 2 plus 2 into, it's a 36 minus 8, negative 1 power 2 plus 3, and this is going to be 20 minus 3. Last row similarly, negative 1 power 3 plus 1 into 15 minus 16 minus 1 power 3 plus 2, third row second column, 20 minus 20, 48. Last one is negative 1 power 3 plus 3, so the entry is 8 minus 18. These are expanded form of this, so if you will simplify it, so your result is going to be negative 7, 49, 28, 13, 28, negative 17. last row is negative 1, 28 and negative 10. So these are the cofactor values for matrix A. So now we have to go for adjoint A. So for adjoint A, which is our final answer for this one, to write the inverse. So adjoint A, you have to transpose now. The first row is going to be first column, and second row is going to be second column, and third row is going to change to third column. I can write down here. So R1 would change to column number 1, R2 will change to column number 2, R3 would change to column number 3. This is what I'm going to do. So then negative 7, 49, 28, 13, 28, negative 17, and then negative 1, 28, and negative 10. So this is my adjoint A. So therefore, I'm just one step away from my final answer. A inverse is equal to 1 over determinant value of A into adjoint A. So what's the determinant value we found before? So it's 49. So I will write here 1 over 49 into adjoint A we recently found. So that's going to be negative 7, 13, negative 1, 49, 28, 28, and 28, negative 17, and negative 10. This is my adjoint A. So you can leave it here, but if you want to go with the entries, yes, you can go ahead. So that's going to be negative 7 over 49, 13 over 49, negative 1 over 49, 49 over 49, 28 over 49, 28 over 49 again. So 28 over 49, negative 17 over 49, and 10 over 49 with the negative sign. So this is the inverse. So if you want to write in simplified form, so that would be negative 1 over 7. Next one is 13 over 49, negative 1 over 49, and second row is negative 1, 4 over 7, 4 over 7. Last row is also 4 over 7. Starting one, negative 17 over 49, and 10 over 49 is the last entry. So this is your inverse by using the formula or determinant method. So you can find it out for any matrix if the order is same. You can say order same means it's a 3 by 3 matrix, 4 by 4 matrix, same number of columns, same number of rows. If you have, you can figure it out, and the approach is exact same. So it's inverse is equal to 1 over determinant value into adjoint A. So how to find adjoint A cofactors and then the transpose of the matrix, and then you can figure it out. This is the first part. The second method is the elementary transformation method. So elementary transformation method is working in a way. So what's the basic approach for it is, so we know if A matrix is equal to I, that's the unit matrix into A. So if you are multiplying any matrix by a unit matrix, it's not going to change anything because that's an identity matrix. But somehow if I will change this A to I, so if I will change this to I, identity matrix, and I would not change this A, that will stay as it is. So then this second I will automatically change to A inverse. Why? Because your I is equal to A inverse of A. So this is the basic approach is working behind the scene. So let's rewrite it and you will understand what I'm trying to say. So let's write A is equal to identity matrix into A. So what my A is 2, 1 and 1, 2. That's equal to identity matrix as you seen before. It's 2 second order. This is 1, 0 and 0, 1. And into the A matrix again. So 2, 1 and 1, 2. So Now what I'm going to use, I'm going to apply all my operations on the first one. So which one is this one, a, and this I. So I will not change this part, so it will stay as it is, a, in my calculation. So let's start it. So if I will rewrite it, it's a 2 1 and 1 2 is equal to, my identity matrix is 1 0 0 1 into, I will say, a. Now I'm going to use one operation on row number 1. So row number 1 would change to row number 1 divided by 2. So all entries are going to be divided by 2. So if I will divide the first 2 by 2, so it's a 1, divide 1 by 2 is 1 over 2, 1 and 2 will stay as it is. So if I will apply the same rule to identity matrix, it's 1 over 2, 0 divided by 2 is 0, and 0 1 as it is into a. So now because I want to make the left side matrix identity matrix, so 1 came on the first entry place, so now I'm going to change second to 0. So what I will do, my row number 2 is going to change to row number 2 minus row number 1. So let's see what happened. 1 is not changing, so 1 and 1 over 2 as it is. So second row minus first 1 minus 1 is 0. 2 minus half is 3 over 2, that's 1.5. And similarly on this side, so 1 would not change, that's 1 over 2 and 0. Second is 0 minus 1 over 2 is negative 1 over 2. And also 1 minus 0, row 2 minus row 1 is 1. So that's the change for the right side one into a as it is. So next part is, now I have to go with the, I want to make 1 in place of 3 over 2 to make it a unit matrix. So what's going to happen now, R2 will change to R2 divided by 3 over 2. So I will divide by 3 over 2, so then I will get 1 in here. So 1 would not change, 1 and 1 over 2 as it is, 0, and this is going to be 1 because you are dividing 1.5 by 1.5. And on this side, first row would not change, 1 and 0. When you will divide 1 by 2 by 3 over 2, so you will get negative 1 over 3. And here 1 is divided by 3 over 2, you will get 2 over 3 and times a. So now I have to change the second place on the left side, that's 1 over 2 to 0. So how I will do it, so my R1 is going to switch to R1 minus 1 over 2 R2, so that will become 0 now. So R1 is changing, so 1 minus half of 0 is still 1, so 1 minus half of 1 is 0. Second row is not changing, that's 0 1. On this side, if you will see, so you have to subtract half of 1 over 3, that's 1 over 6. So you are subtracting, so it means you are adding, so 1 and a half, you have to add 1/6 of that, so you will get 2/3, and you will get here, that's going to be negative 1 over 3, and this is already 1 over 3 negative, and this is a negative 1 over 3. And the second entry is 2 over 3 already, so we'll leave as it is into a. So if you will see now, the left side we have I, and this part, the new matrix, is going to be a inverse and into a. So therefore inverse of this matrix is equal to 2 over 3, negative 1 over 3, negative 1 over 3, and 2 over 3. That's your answer. So these are the methods which are working according to the row operations, but you have to be very careful when you're doing all these operations. And this is also another easy method to find out inverse of any given matrix. I hope you like all these methods. There are a few more things which we can cover in this topic, but they are not directly related here. But furthermore, if I need if there is a demand, or if you guys have any question concerns, please write in comments, and then I will cover I will try to cover those questions in my upcoming video on this, or I will make another video on the same topic to help you guys out. All the best with this topic. I hope this will help for your universities. That's everything. So we try to cover most important, most popular methods to find the inverse of the matrix in this video. There are different approaches. Still, there are a lot of things missing which we can cover. Maybe if there is a demand, then I will try to go back in these things to extend a little more to the next level. Thank you very much. Have a nice day. So please subscribe, like, and share our video so that our channel will be a little more popular, and I will try to do my best in upcoming videos. Thank you. Have a nice day. Bye.